Good evening, everyone. Welcome to the course on Essentials of Data Science with R Part 2. I'm Shreya, one of the TAs for this course, and I will be discussing how you can some problems so that you will have some guidance as to how to solve the assignment questions. All right, so before moving on, I would like to I would like to urge that it's better if you follow the lectures and look at the online recordings weekly and then attend this class. Then I think it will be easier for you to follow along. Otherwise, even though I'll be brushing up a few concepts, but it's always advisable to watch the videos first and then move on to the problem solving sessions. So today I will be discussing week 1 problems or some related problems with respect to the concepts or programming aspects that were discussed during week 1 lectures. So I am going to start the presentation shortly, and I hope you are able to understand what I am saying. And if in case there is any doubt and you need further clarification, you can use the discussion forum that is posted in the NPTEL website. So all you need to do is you need to go to your portal and you will find a Q&A section over here. Once you click on the Q&A, you will be directed to a Google account, Google discussion group, where you can post your conversation pertaining to the problem solving sessions that you would be having, and the TAs and me would be answering your doubts. All right. Okay, so without any further ado, then let's get started on week 1 lectures. Okay, so we learned a lot about how, or we learned a brief overview of what we mean by data science. Okay, it's a very uh, rapidly developing field and it's very in trend right now, and everyone wants to be a data scientist. And Professor Shalab discussed what are the positive or cool aspects of being a data scientist. That is, you get to make the data talk, in the sense that you have lots and lots of information, but you have the capability of transforming that data into meaningful interpretation and apply it across domains to generate useful results, useful predictions, and solve real life problems. So this is what actually is our goal, that we have lots and lots of data and we are going to translate data to information, and that will guide our decision making processes. Okay, and it is actually sort of interdisciplinary between the traditional mathematics and statistics, computer science, and the domain where you are going to apply these techniques to solve real world problems. Okay, and it encompasses statistical analysis, working with databases, and while pursuing data science, you will learn a lot of computational tools and also a lot of programming languages. Okay, these are like not the only but four main pillars of data science that will help uh, in pursuing a career in data science. Okay, so uh, given that, there are several softwares which you can use to uh, carry on your day-to-day work. We will be focusing on this open source software called R. Okay, so in order to use R, it's very easy. It is freely available, open source, and it is a result of a collaborative effort with contributions from all over the world. It's 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 easier. I mean, I find it easier to run, and it runs across all OS platforms. It can run in Windows, it can run in Mac, it can run in several Unix and Linux platforms. So first of all, I'll show you this website. I'm sure you have seen this, but still I'm going to just show you a glimpse of the website. Okay, so you can read up about what are the latest developments in this free software, and you can choose to download R. Okay, you can click here, and this is going to download the software in your system. Now these are you would have to select a CRAN mirror. So CRAN mirrors are essentially FTP servers which stored the same program in different locations. So it doesn't matter which of the locations you choose, you are going to get the same copy of R. So you can feel free to choose any mirror and download it. I will show you. There is there are two mirrors hosted in India. You could use either of these, or you could use any of the others, it doesn't really matter. Okay, so I will be showing you this one. Okay, you click on this zero cloud, and then you would be led on to a page where you will find the download links for Linux, Mac OS, and Windows. Based on your operating system, you can just download. Mine is a Mac, so I'll show you. Once you click on hello, welcome to the course. Hi, Mr. Yogesh. Is the screen visible to you?
Yeah, yes.
Okay. So I just got started and I was just discussing how you can download R onto your system. Is it downloaded in your system?
Yes,
Okay. But still, for the purpose of this video, I'm going to go over it one more time. So, where was
yes.
I? Yes. So, once you are in this portal, you can just click on whichever OS you prefer and whichever is the OS you are using, and you can just click on these packages to download these and follow the regular installation process to get R installed on your system. Once you have this, so you will have this sort of shortcut generated, and once you click on that, the R console is going to open up, right? And
Right.
once you launch the R console, you would be able to see the version that you are using, and you could straight away start coding in this console. For the purpose of bookkeeping, it's always better not to use the console directly, but instead so for the purpose of bookkeeping, it's better if you use script to run your program. So in order to do that, you need to go to file. Yes, so you need to go to file, new document or new script, and something like this is going to crop up. Okay, and you type your code over here, and once you save it, it will be saved in a .r extension. So let's say this one. You could just give example .1 or .r, and this is going to get saved in your document itself. Okay, and you can use this to actually run. So where is this file? Okay, so in a Mac OS you can also use a new RD document, and then once you have your script ready, you can just click on Control R or Command in case of Mac, and then you can execute your script. I personally prefer RStudio. So you would have, in order to install RStudio, you just need to go to this link. Okay.
Right.
Pause it, and it's an integrated development environment, and it's much more user friendly. You get to see everything all at once in the same place, and it uh, essentially helps you code better, because you would have everything, the variables that are loaded in memory, the plots, the console, your script, all at one place. So you can go to this website and download the RStudio version suitable for your OS, go through the regular installation process. You can these are all the other links for Windows, Mac, Ubuntu, and others. So just go ahead, download these, and you would have a console like this. Okay, I will be using this one for the purpose of all illustrations, and I would also urge you to do this. Now once you open the RStudio console, remember, to get RStudio you also need to have some version of R installed in your system. So make sure you do follow these two processes. First you install R, and then you install RStudio. Now this upper left portion is where you would be coding. This is your script. This is the console where you can just see which of the commands is getting executed. Here you would have the number of variables that you are storing. Okay, what are the data types? Everything is listed over here. All right, and if you have single variables which hold certain values, that will also be shown over here. If you have vectors, the data type of the vector will also be shown along with first few numbers. Okay, so this helps to give you a brief overview of what is loaded currently in memory and act accordingly. And you can also check history from here. Otherwise you can also type history in console and check all of these, that's okay. And you can also click on tutorial and go through the packages to learn the
Packages.
RStudio. Once you come to this final plot, you can see all the files that are currently uh, there in the working directory where you are located. And you can also see the plots, you can see what all packages are installed already in your system. The ones that are installed will have this small tick in these boxes, and the ones you don't have, you can just click on one of these and follow the installation procedure, or you can use other methods. And this is the most important and crucial thing, you have a help topic here, because this package is, and this software is very vast, and it's good to know a lot, but even if you know a lot, there's a lot that we will not know. So in that case, this button, the help button, is really useful. Okay. And
Right.
so once we have these, we can just start with a fresh palette by erasing. So you have this erase command over here, which will clear objects from that workspace. So if you click on this, you will get a prompt like this, that are you sure you want to remove all objects.
You.
Make sure you do that, because if by chance you have something loaded in memory but you are trying to use some other version of that variable, there might be some confusion with R and you might get incorrect results. So it's better, if you are not confident, just remove, erase everything from the memory, make the environment empty. Also the same goes for the plots, and then start on with a fresh palette. To clear the console, you can, in RStudio on Mac, you can click command and control and L. This also
You.
works on a Windows environment. Okay, so with
Right.
that I'm going to start, but before starting I would like to know, is there any specific requirement that you want me to address, or anything in general that you want me to cover? Please let me know.
Discontinue it.
Okay, thank you, sir. All right. So once we have this, I'm going to keep two uh, windows in parallel so that it's easier for us to check. All right. The
Right.
first thing we'll have is working with packages. Okay. Now R comes with a lot of pre-installed packages. One of the most useful pre-installed packages, you can also view that in this packages section, is the R base package. You can go and click here and see uh, what are the functions which are hosted in this base package. Okay, if you are not using the RStudio or the GUI version, you can just you can just type here installed dot packages and click on control enter. So here, if you can see, you will get a comprehensive list of what are the packages, where are they installed, what are their versions. So if I do a head of this thing, I'm going to get a smaller version. So these are the columns: package, the path, version, priority, if it has any dependencies. So certain packages, in order for them to be installed, you need certain other packages to be installed first. So these are also mentioned as dependencies and imports linking to the licenses and MD sum and whether it needs compilation and the version, as I was saying. Now this is a lot of information. If you just need the name of the packages, you can just type comma packages, sorry, this is going to
Display the packages.
yeah, 1 second, you just need to type the column name in the with the exact font. So I think I made a mistake in the font. Yes, so see, the column name is package, capital, it starts with package, capital P, and I wrote small p, so this will not work. I need to write package. Okay, so once you write this, you can see what are the packages that are already installed. Okay, now
Right.
if you want to install something which is not there, for example, let me see, uh, uh, let's see ggplot. Okay, so ggplot
GG.
is a useful visualization tool which is I'm seeing is not installed. So what I'm going to do is I'm going to type install dot packages within
GG plot.
bracket and also within quotes I'm going to write ggplot2 and then control enter. So once I do that, you can see this is running on the console and it's downloading from a certain CRAN mirror and it's storing this package in this location. Now once I have the ggplot package in my system, I will further need to load it whenever I am calling this function. So what I'm going to do is I'm going to write library ggplot2. Okay, now once I have that, then ggplot will be loaded in my system, in my session, and then once I click on ggplot2, you will see these sort of prompts will be generated, and you can, if you have something like this coming up, you can just click on tab and then use the other arguments to execute this function. Now I have this ggplot2, but I don't know what arguments it takes. So for help with this specific function, what I can do is I can hover over ggplot2 and click on F1. Okay, so once I click on F1, this all information about this package is going to arrive in this fourth, in the help section. Also I could just type question mark ggplot2. Okay, that will
Right.
also open the same help portal. So if you have a function you are not aware of and you don't know the its arguments functionality, you can just go and check in the help button by either clicking F1 or just giving a question mark before this. Okay,
Right.
and you could also specify something like this, that is library help equal to then your package name, so ggplot2. What this is going to do is that this is going to open the documentation in this upper left corner, and you can see what other components you have to use along with this ggplot functionality. All right,
Right.
okay, so once we have that, And these things I discussed, how to clear screen, and quit helps
That
when we are using mostly the terminal. Otherwise, for this GUI version, we can just close it. That's okay.
closer.
Yes. So in case you are using a terminal, then you have to just type, you have to see the location of your R binary, and then go there, write R script, and then your script name, and then .r, and then pressing on enter will execute the R script in a terminal setup. So if you're working on Linux, make sure you have the .r file stored in some location, and you just have to give R script and the path to that location. Okay, so once this is done, the next thing that I'm going to discuss, and very extensively, is using R as a calculator for all sorts of operations. Okay, so let me just save this file. So this I'm going to save as week 1. Okay,
On saving this file, ma'am, this will go to the library or
no, this will save where you want it to save. So I have a folder, let's say, which is dedicated to this course, and I can just click on save as,
okay, locally we can save
and
it.
locally it will be saved. Okay, this is not being saved to library. Whatever packages you load or install, those will be uh, saved to the library. Alright, okay, so let's proceed. So this one, we are using R as a calculator. So the first thing is the assignment operator. So let's say I want this variable name to store my name. So I'm going to write name, and then I could either use equal to and write my name within quotes. So what, or I could just write my name, and with this less than and hyphen, which shows that I am directing my name to be stored in this variable. Okay, so
Right.
both of them will store the same thing. So here if I click, if I run it, then I can see that my name is stored as in the variable name, and name2 will also have the same thing. So it doesn't matter which of the assignment operations you use. Similarly, if you want to perform addition, 5 plus 2, you can do it. Now this will not appear in the environment because you are not saving this value to any other variable. Okay, so if I write add equal to, so add will store 7. Similarly, I can do minus 7 minus 9, something like this, minus 2, multiplication 6 into 2, division 4 by 2. Done. Another thing that is often helpful is raising something to the power something. Okay, so exponentiation. So to do that, you can use this caret symbol. So if I want 8 square, I can write 8 to the power 8 caret 2. So I should get 64. Okay, you can also replace this with double star. You would get the same thing. So if I give 6 star star 2, then you will also get 36.
Square.
Okay, so single star is going to do multiplication, double star is going to give the to the power of
Exponential.
exponentiation. Yes. Another important useful thing is the modulus thing. So if you want to perform a division and you just want the remainder term, that is when the modulus operator is very handy. So let's say I want 4 divided by 3, okay, and I want the quotient. So if I just run 4 by 3, it's going to give me some floating point number 1.33. If I want the remainder, I have to give 4 percentage 3. So see, now I get the remainder as 1. And in case I want to get the quotient, then I should probably give 4 percentage divided by percentage 3. In this case both are 1, but I can just improve this, let's say by using 14 divided by 3. A modulus, it would be 3 4s are 12, remainder is 2, and 14 by 3 quotient will be 12, sorry 4, yes. Okay, now while using these operators, usually the BODMAS rule is followed. Okay, but
Right.
if there are expressions where we have these arithmetic operators coupled with some others, then R follows this operator precedence. Okay, first will be
Right.
brackets or parenthesis, then the exponential, then we have the unary operators. So let's say I want to do uh, minus 7 into or minus 7 plus 5 into 4. So first it will convert 7 to, sorry, first, so it will follow this order. So it will first convert my 7 to minus 7 and hold it in memory. Then it will perform 5 into 420, and then lastly this operation. Okay, so we'll get 13. This is the order. So if this can become tricky if we want a certain operation to be performed and we forget this order of precedence, then we might get incorrect results. So if we want to enforce that something happens in the order that we want it to happen and we don't want to bother looking at it again, then the best way to go about is using parenthesis. Just not keep anything in their hand. Strictly specify what is going to happen and how. So if I wanted this, if I want minus 2 into 4, I am going to give this and then into 4. Okay,
Right.
right. So this I will anyway post this document in one of the Google Drives, and you will have access to it via the
Excellent.
NPTEL website, so you will be able to look at it.
Ji.
Okay, so once these are done, the logical operators, then comes the arithmetic operators, and all of these multiplication, division, modulo, remainder, quotient, all of these have the same level of precedence, and operations would be performed left to right. Okay, so let's just test out this thing. uh, let's say I want something like this: 8 into 5 by 5, uh, let's say 8 into 5 by 2, something like this, and then modulo 3. So as per this document, it should happen that 40 by 2,
2
okay,
minus 3.
and then modulo 3. So it should be 20 modulo 3. It should come to modulo, sorry. Yes, it should give me 2. But it's not giving 2. So what is happening? 5 by 2. It's 2.5 into 8. I think this is what is happening. It's actually typically following BODMAS. Yes. Okay. So they will have the same order of precedence, but still BODMAS would be followed.
Follow.
Yes. So I'll just make this comment here. Yes. Now after these we have our relational operators, which the output of these relational operators is either true or false. Now if I want to see whether the name variable is equal to Shreya or not, so what I'm going to do is I'm going to write name equal to my name, and it should return a true value, and it's returning a true value. This, mind you, is very case sensitive, so if I write this thing instead, I'm going to get false because the strings don't match. So when you are using if-else statements, especially with these character types or string variables, be very careful of the case of the string. Even if one is off, then your entire thing will be false. Okay, so this is the equals operator. The other one is not equal to. So if I just type name exclamation equal to is not equal to. So name exclamation equal to shrey small, if I give, then here I'm going to get true value because the name variable is indeed not storing this string which starts with a small s. Alright. The next one is less than or greater than. So if I give 5 less than 6, it should give me true. If I give 5 less than 7, it should give me false. Similarly for greater than, so less than greater than I demonstrated. Similarly for less than equal to, and this one will give me true, and this greater than equal to is going to give false. Okay. The next one is logical and logical or. So this one you can use a single and or a double and based on whether you are comparing one scalar or one vector. And what it does, it helps to combine or couple different expressions. So if I want to test whether if let's say 5 less than greater than equal to 3 and 5 less than equal to 6, so this one is true.
Which one's false?
Because both the conditions are satisfied. But if one fails, then I'm going to get false. If I give 4.9, then I'm going to get false.
False.
Similarly with logical or, even if this is there, if I have one or, then it's going to return true. If both are false, only then I'm going to get false with the logical or. So if I give 5 less than equal to 3 and 5 less than equal to 4.9, so since both these statements are false, so I will get a false. Otherwise, any other, even if one is true, I'm going to get a true value. Now you have to be mindful of this when I'm comparing scalar quantities. Then one and
One
one
and
or is going to work, but if we are comparing vectors, then double
two.
and is going to work.
Yes.
uh, Let me just check once more. Let's say I have a vector called x equal to 1 and 2. So if I want to check x greater than 0 and x less than 3, it's not working. So single and will work in this case as well. But there are cases where I have also personally faced, but now I cannot remember. I'm going to fetch that example and show you. uh, so here what is happening here, even though this is a vector, essentially it is comparing all the elements of these vectors.
Here, vector means we are equating with the vector quantities, ma'am.
Yes, individual elements. So we are
Yeah.
actually comparing individual elements of this array.
Okay.
So here for the first one we see true, for the second one also we see true. Okay.
Yeah.
I can't remember this double ampersand.
Double
Where,
ampersand is
let me see here if this works here. Oh yes, now I remember. So for scalar quantities, double ampersand is also going to work, but for vectors only a single ampersand is going to work. Yeah, now I remember. So see here, when you were comparing, when we were comparing only scalars, one quantity to each other,
each other.
then it doesn't matter whether we use a single ampersand or a
Single.
double ampersand, it's going to work. But when we have vectors, then this double ampersand is not going to work, because uh, we are, in essence, it needs to compare each elements of this array. So in that case only a single ampersand works. Okay, this is
Okay.
particularly helpful if you say have a column of numbers and you want to prepare another column based on that with some if else condition. Then this helps a lot, because instead of, I mean, in R, it's very computationally intensive to run a loop, especially a for loop or a while loop. So to simplify those to reduce computational time and simplify the overall, optimize the overall operations. So R uses this concept of vectorization, and if you use such logical operators, it's easier for it to check element wise and then assign another column on the same index as the previous one. I might not be very clear now, but as we move on to do a lot more, this concept will get even more clearer. And lastly, we have this this assignment operator. Uh,
Sorry, ma'am. Just I got delinked.
oh, okay, fine.
I'm back now.
That's okay. Thank you so much. So, yes. So, what I was saying is, at last, the last precedence is this
Assignment.
assignment operator. So, if you have a lot of things going on and then you assign something, so for example, here are some practice questions. So predict the outcome of the following: 7 plus 8 into 4, something like this, let's say. So if I write a equal to this thing, so first the operators, first this parenthesis, then this multiplication will happen,
Multiplication of
and
4.
then whatever the value is there, that will be assigned to a, in the
A.
sense because a, this equal to operator has lowest order. So yeah, it will come as 60.
60.
Okay, the next one is this one. Can you say what?
2 raised to the power 3 plus 4.
This would be
So 8
12.
plus 4. 12.
This would be 12. This one is okay, another
7
basic thing,
multiplied by
minus
6.
42.
42.
Okay, what will happen here?
5 divided by 2 is 2.5. And 4 into 2, 8. 8 into 3, 24. So 3 plus 27 minus 2.5. 24.5.
No, here
No.
this exponential thing will act first because it has higher
Okay.
precedence.
Okay,
So
yes. 2 raised to power 3 will come first.
yes,
So 8.
so
I
8
thought
will come
actually it was
first.
multiplication.
No, this is
No, it was
exponential.
2 raised to power 3.
So 8
8.
minus 8 into 4 minus
8 into 4,
2.5,
32.
minus 2.5
35,
plus 3.
2.5. 32.5.
Yes, so this is going to give you 32.5. Okay, let's have something like this. What do you think will happen?
3 into 2. That is 6 plus 6 in goodness 3 into. This is 5 plus 3, na? 5 plus 3.
This is 5 plus 3, yes.
5 plus 3. 3 into 2 is 6 plus 5, 11. Is more than 10. What is the next question? Let me see that. The screen, the backside screen is not okay. 10 into is more than 10 ampersand 4, less than or minus, less than or equals to 5. Less than 4 minus 4 is less than or equals to 5. No, that's not true here. But 10 ampersand. This we need to solve, man.
Okay, so first these the Bodmer's rule is going to apply. So here I have 3 into 2, 6,
6
plus 5 is 11. So this in essence will be 11 greater than 10
greater than 10,
and 4 less than equal to 5.
less than equal to 5.
So 4 less than equal to 5 is true, and 11 greater than 10 is also true. So this one should either give me 1 or true value. So let's see what it gives. It gives true.
True value. Okay.
And if I just want this as a numeric thing, I am going to write as dot numeric okay. So why it is better to convert true variables to numeric is that if you want to make a count of number of trues, then you just need to do a sum over that variable, and then you can directly get the number of true values instead of counting if this equal to 2. If this is true, then count. Even though R has you don't need to do that in R, but you might need to do it in some other programming languages. But it's it's one of the options. If you want things to be true values to be stored as 1, it can get computationally easier for certain cases. Just a thought. Okay, so This is
All
what
right.
happens, and you have to remember this operator precedence. And if you want something
But this will return, ma'am. This just sorry, ma'am. This as numeric
as
when
numeric
we
is going to return number 1. So what happens is that our let's say in the back of its mind will have true values coded as 1 and false values coded as 0.
okay.
Okay, so
Here it will
uh,
return one.
here first, if I am not giving as dot numeric, let me store this value as something. Okay, let me store it as p. So p is actually a logical value, it's true.
True.
Okay, I could, I think, also use strp to
Right.
look at what data structure it is. Str is a helpful command. You can look up, which gives you what is the structure of the variable. For example, if I give strx, I can see whatever is represented over here. It's a vector of type numeric, in the sense that numeric values are being held in this vector named x. Similarly, if we give str add, then it's also a numeric type. Str name should is a string type, so it should give me
Yeah.
character. Okay, it's a
Okay.
character type variable, so the data types would be specified here. Now if I store this thing, then the data type structure is a logical value, either true or false. But if
False.
I give str as dot numeric p, then it is converted to a numerical variable. All right.
All right.
Okay, so this was all about the operator precedence. Now let us move on to data types and vectors.
Okay.
All right. Yes. So if I want, first thing is vectors. So vectors is equivalent to arrays. Okay.
Raise.
Yes. And how do I create a new vector? So my vector equal to, I'm going to use this c, and within braces whatever I write, comma separated. So the comma is going to uh, tell me how this vector is actually stored and which are the elements of this vector. Okay, so uh, if I give 1 2 3 6 7 8 9, then my vector is a vector of length 7, and it stores these in
1, 2, 3,
in
6, 7.
contiguous blocks. Okay,
Hmm.
uh, for r, the vector indices start at 1. So what I mean to say is that, um, just give me a minute. um, so if this is my r vector,
Okay.
am storing this 1 2 3 4 5 6 7. So this is the my vector that I am
I
storing, and here I am storing say 1 2, and what else did I give? 3 6 7
one
8
three
9,
six
let's
seven
say
eight nine. One three
3
six
6 7
eight
8 9.
7 8 9.
Now all this array has an index. How it is, R is remembering it. So for R, the indices, it's plain and simple, it starts from 1 1 2 3 4 5 6 7.
Seven indices.
So
Indices.
yes, 7 data blocks, you can say.
Data blocks.
Yes. Now if I want to query the third element, all I need to do is I need to write my vector, and then within third bracket I have to specify the index, that is 3, and this is going to give me the output as 3.
Three.
Okay, why
In
I am
case
telling
I
this?
say five, then it will be
It will
seven,
give
right?
me 7, yes. So my vector 5 is going to give you 7. Why I'm saying this about indices is that because it differs across programming language. If you are using Python, then the indices start at 0.
Okay.
So this holds for Python, but in R it's very straightforward. And if you are using multiple languages for your work, it might get confusing. So just to be clear, for R it's very straightforward. Whichever number you want to query, you can just query it using this um, index. So if I go back, let me just check whether I'm right or not. So
My
you
vector.
want the fifth
Okay.
thing, so it's giving me 7,
Seven.
right? Right. Now oftentimes, let's say we have a large vector. Okay, so uh, let's say I have a very huge vector over here, and it ranges from, let's say, 1 to 10,000. Okay, so
Okay.
let's say I'm holding some census data or something. Now I want to see, or I want to view uh, data where the block, I mean, where the data itself is some number. So I could have 5 in 501st position. I could have 5 in, let's say, 20th position. I could have 5 in the 9999th position. Okay. I want to find out. So in essentially what I am trying to do here is that I am finding out which indices hold 5.
Source five. Hold five.
This is my question. And to solve this, the keyword is also which.
Okay.
Okay, how I'm going to do that? I'm going to write which my vector equal to 5, and then this is going to return me indices 20 501 and 999.
Okay.
Okay, I'll
Number
just,
of indices.
yes, so let me just illustrate it with a small example. So let's say I have
Is
my
my
vector
vector to
2
C. My vector.
equal to, I let me keep 1 to 10,000. This is another colon operator which is actually generating a sequence of numbers 1 to 10,000. And I want those numbers which are multiples of 5. Okay.
Multiples of 5.
Okay, so I want to know indices where multiples of 5 are stored. Uh, so here, since it starts from 1 to 10,000, it is easier to calculate that way. So I'm going to change this one a little bit. I'm going to make it 2 to 10,001. Okay, so I'm going to I shifted the data set by 1 point, so that the wherever I have multiples of 5, that index is actually 1 less than what my 5 multiples of 5 would be. Okay, so I have this. Now I want to find out what is my criteria. I want to find out which my vector 2
vector
is divided by 5. So it's divided by the this is modulo by 5. Modulo 5 equal to 0 means when I divide by 5 there is no remainder.
no remainder.
Okay, so this will give me 4, then 9, then 14, and so on. Okay, my vector is not there in memory. So this is my vector 2. It stores 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you see 4th index, 9th index, and plus 5 is going to give me whatever I want. So this which, see, it's giving me so many indices. And it starts from 4, 9, 14, 19, 24, 29, and so on.
Okay. Thousands.
Okay, now it's too long. I want to know what is the length of this vector. So if I just give for my vector this small 7 position vector, if I give length, very straightforward length, my vector is going to give me how many number of elements are there. So I have 7 elements in my vector.
7 elements.
Now I want to know how many elements are there are divisible. So this one is giving me where the multiples of 5 are stored.
5 is stored.
Yes, and next I want to know is how many multiples of 5. So I already had this. This is actually, if I do an str, you will see this variable is actually an integer array, and it goes from 1 to 2000. So essentially there would be 2000 elements over here. But to be sure, we can just write length and then this which command, and then it's going to give me 2000. Okay, so this which command is very useful, and I can use it to query anything. For example, if I want to know which or how many greater than 887, so I'm going to write which my vector 2 greater than 887, and it's going to give me that indices. So 887, 888, 889.
Okay. One.
if I want to see what is stored in this 887th element, my vector, mind you, this is actually the index. So 887th index will actually store 888. That is why it is coming. Okay.
Okay.
So if I give 887, sorry, my vector 2, then it is actually storing 888.
888. It will be counting from first or second. It will be counting from
It will
second.
be counting from first, but the array that I have designed starts from second. That's why I'm getting this. So if, let's say, this is the array,
Okay.
I am starting it from 2.
Two.
This is the first position,
Okay,
this
okay,
is the
two.
second
But
position.
okay, the
So this
first
is
disk is storing 2.
887th position. Yes.
Mm.
So if I just change it to something random, then also this is the index 1 2. So if I go forward 5 20 39 78, let's say 78 is stored in 887th position, I could very well do that. But don't get confused because of the nature of the example that I'm using.
Okay.
Okay. uh, it could be anything. Whatever I am specifying here, 887, this 887, what I'm specifying in argument is actually
Yes.
inside the boxes, and what
Okay,
which
two.
is throwing me is actually the ones above the boxes. Okay, so which is
Yeah.
actually going to give me indices. It is returning indices. Now this is how you add comments to your code. You write it anywhere, but before inserting any comments, you just put a hash sign, and
Yes.
this will not get executed. The only part which comes before hash, that will be
Yes.
executed. Yes. Okay, so this was another thing that I could do. Similarly, similar to numeric vectors, I could store uh, string vectors. So let's say I store seasons, winter, summer, monsoons. This would be my seasons vector, which you can see here is a character vector. In the sense, it is storing strings. It could also be a logical vector. So logical vector would be without quotes and in all caps: true, false, true, true, false. Okay.
Okay.
Now if I, so this is where I was telling I can convert logical values to numeric values and get straightforward results. So let's say I have a true false scenario for 10,000 times, and I want to know how many trues are there. So I could select which logical equal to true, or, oh, okay, I don't even need to give uh,
Equal to
equal
logical.
to
Which
argument
logical?
to which is not logical. Okay, logical is this thing, and then I give which logical. So it is going to automatically throw the indices where I'll have true. So if I have a logical variable which logical equal to true, and not specifying this equal to true, is going to give me the same result.
Okay. 1 3 4.
Okay, because this
Hmm.
one implicitly will execute and find out whether it's
Hmm.
true or false, and then it will give us the indices. Okay, now I have 3, and I could just count or use the length variable command to find out how many trues are there. Another workaround, as I was telling, is convert it to numeric as dot logical, as dot numeric logical. Then I'm going to have 10110, and then just do a sum of that. Different ways of doing the same problem. All right. uh, R can also handle complex uh, variables, complex real and complex data. So if I have to store something like this, complex numbers, I can do that. 1 plus 3i, 4 minus 2i, etc., etc. This also holds, and the data type would be complex.
Complex.
All right. Now, this these are all sorts of data types where you can store in a vector. Now, mind you, when the data structure is a vector, then all elements in that vector should have the same data type. So let's say you have something like this. uh, you have a vector where you want to store 1 2 3 over here, and you want to store a, b, c here. This is not permitted if you are using a vector, because if you are using a numeric, then all should be numeric. If you are using a character, then all should be character. So if you have mixed data types, you have to be careful with mixed data types. It will usually not happen when you are giving variables as inputs, but this usually happens when you are reading from a file, right? So
Hmm.
you might have certain rows, let's say for IDs, where all the IDs are some 10 digits or something, and somewhere you have a name inserted, because mostly all the files that we work with, some could be actually coming from surveys, and there could be uh, it is possible that it's not completely digitized, and you may run into issues while reading such files. Large files will come with its own set of issues. So in those cases, you will have to be very careful, because the usual format in which these data is loaded will mostly mimic or will mostly satisfy this thing where one column will be represented as a vector. If you use a data frame structure, which is the most common one, we'll come to that shortly. If you plan to use that, then each of the columns will be stored as a vector. Then you have to be sure that all the elements in your column that you are loading are of the same data type, and depending on that you might need to change your data types. So if I have to store 1 2 3 abc in the same vector, it has to be stored as not numeric 1 2 3, but like this, as a string. Okay, so
Right.
just keep this in the back of your mind. We'll touch up on this later. So that is why it's important to know this str command. If you have something, have a data frame
Yes.
or anything, use the str, and you'll be able to see what the data type is of each and individual column. Alright, okay, so let's move on. Now we want to perform operation in each element of the vector. So let's say I have this my vector data set. Okay, one more thing I want to tell you. Let's say I have too many variables here. I want some, I don't want some. If I just give this command, it will clear all objects. But if
Okay.
instead I write rm add, then I can remove one by one. Okay, so I'm going to remove a. I don't need this complex. Okay, let that be there. uh, okay, and I don't think I'll need this logical variable, the name ones. Okay, you can remove one by one, or you can remove in bulk by giving a comma separated list. So rm c, I don't need p, I don't need x. Oh, sorry, must contain names or character strings. I see. So if I give p, no, this is not working, so maybe this is the only way forward. Fine. So I'll just remove my vector 2 also for the time being because it's too large. Okay. Let
Okay.
me just work with these in the space. Now I have this my vector numerical array. Now if I write my vector into 2,
Two.
what will happen? Each element, sorry, in my vector will be multiplied with 2.
Right.
So we see 2, 4, 6, 12, something like this. Now if I want to do a division, I could do that. If I want to do multiplication, I can do that. If I want to add, I can do that. If I want to subtract, I can do that. Now next thing is I want to add uh, index to each element.
Element. Okay.
Okay, so what I want to do is this is 1 2 something something 3 4 9, and this is 1 2 3 4 9 something. I want 1 plus 1, 2 plus 2. Okay, I'll just write 1 2 3 6 7 8 9. This is what I want. So I want 1 plus 1, 2 plus 2, 3 plus 3, 6 plus 4,
6 plus
7 plus
7
5,
plus
8 plus 6,
8 plus
and 9
6.
plus 7. This is what I want. So what I'm going to do is, first is I write my vector and I add this element. So 1 2 9. Sorry, 1 2 7, the length. So that is what I get. 1 plus 1, 2 plus 2, 3 plus 3, 6 plus 4. This thing. Let's say I want to do something like this. I want to I have this vector. Okay, I want to add 1 2, then again 1 2, then again 1 2, then 1. So what I'm going to do is I'm going to write my vector plus c 1 2. So I will get a warning message like this, that longer object length is not a multiple of shorter object length. But what is going to happen is that this will function in a round robin manner. So
Okay.
so if I just run this thing and I run this thing, you see 1 plus 1 is 2, 2 plus 2 is 4. Again 3 plus 1 is 4, 6 plus 2 is 8. 7 plus 1 is 8, 8
Yeah.
plus 2 is 10. So the 2 2
The second
orders will
element is
end here, and then again it will start looping over from 1. So 9 plus 1 will be 10.
10.
Okay, same thing is going to happen similarly if, I mean, you are going to get that number whichever vector length is larger. For example, if I want to give my vector is of length 7 and I want to add a 9 vector. So the length of this new vector that I'm creating right now, that will be 9. So if I give my vector plus c 1 to 9, what is happening is 1 plus 1, 2 plus 2, 3 plus 4, 6 plus 10, 7 plus 5, 8 plus 6, 9 plus 7, again
9 plus
9, 1 plus 9,
1 plus
1 plus 8, sorry, 1 plus 8,
1 plus 8.
and 2 plus
7
9.
plus 9. 2 plus 9.
Okay, so this can happen. Now I want, uh, let's say, okay, these things are done. Similarly with exponential or something like that. Yes, now I have a, the next thing is I want to query. Okay, let's say I have a large list of numbers, x equal to, I'm writing sample 1 to 10,000. We'll come to these functions. I'm just randomly generating 10,000 numbers, or sample 10 from, let me just do r unifor. What can I do? Let me just see what the sample function is doing. Okay, either a vector of one of which to choose. So if you go down, then you will find examples as well. So yes, I'm going to sample from 1 to 10,000. I'm going to generate 80 numbers. Let me just do this. So here I have this X column. I have generated 80 numbers between
Okay.
1 to
From
10,000.
10,000.
Okay, so this is 80 numbers 1 to 10,000. Now
Replace true, what that command
this
source
means
meant.
sampling with replacement.
Okay, with
So
replacement.
which means that there could be repetitions also.
Okay.
Okay, Repetitions
Yes.
will tend to be lower when we are sampling over a large number, but if I am sampling from 1 to 10 with 80, so I'll have
Repetitions.
more number of repeated samples. Okay, so once this is done, now I want to see, now too many numbers are here, and I want to check whether this number 2 is actually present or not. Now here I can see readily, but let me just increase this to 20. Okay, and readily I'm not able to see any 2. Okay, okay, here
The
it
first,
is. The first one
first
is
was
here, but let me think of please think of a number which you
10.
cannot readily see.
Okay, 1, 2, 3, 1 to 10. 8 is there, 7, 6. 6 is also there, 5. 5 is there, 4. 4 is also there, 3 is there, 2. 2 is there in third row.
Okay, so the
2
point
is.
is, here number is less,
1,
I can go and see, but if I just
1 is not there. 1,
1 is
1 is
also
there.
here.
1 is there,
So
okay.
the the problem is, if I have small, it's okay, I can just manually go and check in. If I had generated, instead of 80, if I had generated 1000 numbers, and then I want to check whether it's present or not, it's not possible to do that.
Yes.
In such scenarios, what I'm going to do is, I'm going to search if 4, or if I can see 4, so let's say whatever I cannot see readily, let's say 18, I cannot see any 18 right away. So 18 percentage in percentage x, what this is going to give me, it is going to show, it is going to return the positions, or whether 18 is present in x or not. It's not going to return the position, it is going to just tell me whether this 18 is present in x or not.
So it is present, I think. So
It is
this was
present, it
true.
is giving true. This is like a find command.
Find command.
Yeah, if I have a lot of names, 10,000, 3,000, 7,000 names, and I want to find
Mm.
whether I have a particular name listed there in that vector or not. So what I'm going to do is that I'm going to type that name, percentage in percentage x. So this percentage in percentage is the in operator, and it's going to return true if it is present, it's going to return false if it is not present. So I sampled from 1 to 20. 21 will not be present, so it's a given. So I'll just search if 21 is present. No, 21
False.
is not present. Okay.
And this video will be available.
Yes, this
On the,
video will be available, and this document, everything will be available to you. Don't worry. So uh, this is there, and yeah. So what I was telling, now I know where, I mean, now I know that it's present.
yes.
Now, if I want to check where it is present,
Mm.
then will, if I type which, do you think it will work?
Which was related to which command? Which
Which is actually giving me, if I give which some condition, it's going to give me positions where the condition
position?
is true.
Okay.
So, do you think which is going to work here?
Which is it shall work. No.
I don't think so, because here you see this is actually returning a true,
Okay.
and which true will also return a true. So it is going to give me just one value, just C, or nothing. Oh, 21 will give me nothing. So 18, let me just see if it's giving. No, it'll just give 1, because first it is going to evaluate what is between the parentheses. So between the parentheses I only have true. I don't have true true false false true true false false, something like this. That will happen, so this will not work. If I want to find out the positions, so
21% in percent.
so this will also
X.
give me false. If I want to find out the positions, I will have to give which x equal to 18.
21. 18.
Now if you only run x equal to 18, now in R, if you just only want to run a particular section, you select it and then press Control Enter. See, x equal to 18 is giving me all sorts of positions. It's looping over all the positions and giving me whether that element is equal to 18 or not. Now if I do which x equal to 18, it is going to give me the indices. So x5, if I see, it's 18. x332, it's 18.
8.
Yes, like this. Okay, so when we have complex statements, we have to start with the innermost one. So the innermost thing will get executed first, then the next parenthesis, then the next parenthesis. What was happening over here? Okay, so if I just write let's say the same thing, if I write this thing and then I give a length, so how R is executing? First R is executing x equal to 30,
X is equal to.
then it's
Okay, okay.
finding out which, and
Which
then on top of that it's finding out the length. So the number of times
number of
18 has
routines?
appeared is actually 42.
Okay. Okay.
Okay, right. So this is what we do. This is accessing a particular vector element with the help of indices, checking whether a specific number is given, number of elements with length. All right, another useful tool is this sequence operator. So if I want to populate a vector, let's say 1 to 10,000, I could go on and do c equal to 1 comma 2 comma 3 and dot 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 dot. I could do that, but that's time consuming. If I know that my vector is going to follow a certain pattern, it's going to come, it is going to have consecutive elements, I could just write c1 begin end number 6 and y equal to 1. It's essentially the same thing as writing c1 is to 6. Both will give me the same thing. Now I want a vector of even numbers, let's say. So I am going to give x equal to c0 to 40, and so 0 comma 40, not colon, 0 begin end, and y equal to 2. So then this is going to give me why is this not working? Oh sorry, not c will not work, sorry, really sorry. Here I have to write sequence, a seq.
Sequence.
I'm generating sequences, yes. So sequence, this thing, sequence, this by default gives only consecutive sequences, and this one is going to give me the odd numbers. So now if I type x, I'll have all the even numbers, sorry, even numbers. If I want the odd numbers, I'll start with 1 to 40 and I'm going to get all odd numbers. Similarly, I can generate any um, sequence in this manner. I just have to give the beginning, the end, and then uh, just this thing. If I want to generate the squared odd numbers, then what should I do? Same thing. This one
Sequence.
has generated odd numbers. Now if I give caret 2, then it is going to generate the squared odd numbers, because this one on a vector is going to act on each individual elements of that vector. Okay. Next thing is, I want this variable and I want to loop it over multiple times. So I want, let's say I want this 1 2 3, then again 1 2 3, then again 1 2 3, and this I want n times. This is something that I want. So this one, to do this, I need to use this rep command, replicate. Which string I'm going to replicate, which vector I'm going to replicate? I'm going to replicate C 1 2 3, and how many times I'm going to replicate? 10 times, let's say.
And
So
okay,
it's going to give me 1 2 3 1 2 3 1 2 3 10 times. Similarly, if I want to write 1 1 1 1 n times, then again 2 2 2 2 n times, and so on. Excuse me. And similarly 3 3 3 n times. This is what I want. Then I'm going to write this thing,
repeat.
each equal to 10. So then I'm going to get this thing. So 1 repeated 10 times, 2 repeated 10 times, 3 repeated 10 times. Now I want 1 repeated once, 2 repeated twice, 3 repeated thrice. So I can write each equal to, and here I specify how many times I want each of them to be replicated. First element used of, oh,
1 1
no, it's not working. Replicate each equal to let me just look at how to make this work. So help section, times will just replicate the entire thing. Yes, I don't need to give this a each command. I just need to specify this thing.
1 2 3.
Yes. So this will replicate 1 once, 2 twice, 3 thrice. So I was stuck here, but this helped me out. With these examples, I was able to manage.
How we are going to help from here?
So I went to replicate, and then I clicked on F1.
F1. Okay.
Yes. Or you can just type question mark replicate. That will also open the help tool.
Okay.
Okay. So this was all about sequences. Okay. So R also has some built-in commands which you can just use, minimum, maximum, range. So I'll just use all of these in this X column that I have. So sum X is going to give me sum of all elements of X. This is my X vector, sum of squared elements.
Okay.
Okay, mean x is going to give me
Already.
an average, median is going to give me the median value, SD is going to give me
Standard
standard
deviation.
deviation. Now, mind you, standard deviation, uh, yes, this is something you should keep in mind. Where is that thing? So, in the usual standard deviation formula, how do we calculate standard deviation? It's actually summation xi
Summation
minus x bar whole square 1 by n and square root of this thing.
under root.
Now in R, SD is actually this thing.
Mm.
So you might face,
-1.
yeah, the denominator is -1. So you might
Mm.
face some sort of discrepancy, but just keep this in mind. Okay, right. So these are some of the inbuilt things.
Commands.
SQRT, yes. So uh, ABS is actually will give you absolute values. So ABS of -7 is going to give you 7. Okay, and floor round, these are actually for rounding up or down. So let's say round, if I give 0.0032 to 4 decimal places, it will give me 0.003. Okay, similarly, if I give floor, then also it's going to give me 0.003. Two arguments, floor requires one. Okay, but how do I specify the, there has to be something which specifies the precision I want. So let's go to floor help. Okay, seems like floor is going to just round it below and above. So if I, it requires 1. And if I do ceiling, then I think I'm going to get 1. Yes. uh, yep. So floor and ceiling, they always return integer, as
Integer.
is also specified here. Takes single numeric argument and turns the numeric vector containing the smallest integer not less than equal to corresponding elements. Okay, so you could also explore this trunk and signif values if you want. Okay, and these are the sum, product will just multiply all the elements. Exp will give us the exponential value of
Export.
each of the elements. And log 2 is actually log base 2. You could change the base by using log 3, log 10, whatever you want. Sine, tan, cosine, something, square root, all of these you'll be able to do. Now if you just want, can you just try out how to do this? So if I want to go ahead and do this, where my data x equal to c1 to 10, and I want to find out this expression. So this is actually summation xi square minus n x bar whole square. So to do that, this is actually n into, or here in this case n minus 1 into variance, but let me just go normally and see how to do this. So x is this thing, and this right hand side is simplified to this part. So first thing is I need to square each element of x. So I'm going to do x square, and then I'm going to do a sum of x square. So x square is giving me 149,200, and then sum of n square is going to give me this quantity minus n. N is what? The length of the vector. So length x into x bar is what? Mean of the vector, mean x whole square. So mean x square. Now to be very precise, I am going to use brackets. So first things first I'll get mean x, then I'm going to get mean x square, then that will be multiplied with length x, and then that will be subtracted from this thing. So it is giving me 82.5. I will get the same thing if I do var x into
Variance.
9. Why 9? Yes, because
N minus
this is
1.
n minus
N
1.
minus 1.
Exactly. So this is actually variance n minus 1 by n. Sorry, this one is n minus 1. No, sorry, this is n var n minus 1. So this adjustment needs to be done over here. Okay, this is how you
82
can use inbuilt R
command
functions, sorry,
functions.
to go on. The next thing is handling missing data. So let's say you have x equal to c 1 2 4 5 and then na 4, something like this. So if I want to check if uh, we have na or not, so I'm going to do an is.nax, and that is going to check each element and give me whether I have na or not. So in
Any.
this case, the 1 2 3 4 fifth element is returning true, which means that the fifth element is na. Okay, so now if I do have missing values in my vector, then these inbuilt matrices will also return me an na value. So if I give mean x, it's going to give me na. If I give sum x, it's going to give me na. If I do prod x, it's going to give me na. So what I need to do, if I am desperate to find out the mean, product and sum, irrespective of whether there should be an na in the first place or not, then I need to remove the na and consider the uh, variable or the function. So in that case, I'm going to write sum of x na dot rm equal to true. So what this is going to do is, it is going to remove the na column and then take a sum. So if this was my x vector, it's taking a sum, not considering the na value. So na dot rm is going to take care of those situations. If I just want to do a prod x with only the available numbers, same thing, na dot rm equal to true. Now if I just want to make a whole new data set by removing the whatever nas I have, then I can do na dot omit x. Then I am going to have this thing. Okay,
Right.
another class I'll have, and na dot omit, let me just, this is a complex sort of a data structure. So you see, it's actually a string, a numerical variable. So initially I had 6 elements, now I have 5 elements in na dot omit. Okay,
Yes.
Another thing is that if something exists but is missing, we'll have na, but if nothing is present, then we will have the data
Mm.
type as null. Okay, and na n is will indicate an undefined value. So if I give 0 by 0, I'm going to get na n.
Mm.
Okay, and null is uh, let's say, how can I say, so if I give x equal to array like this and write x, then I see any, uh, I have to find out how to simulate a null result. But if nothing is present in any
Mm.
uh, sort of variable, then you would get
Yes.
an
Amen.
output of null. Okay,
Jannah.
yeah. So again, if you want to replace this missing data, if you want to replace na by 0,
Mm.
then what you need to do is, okay, so x is this one, I want to replace na by 0, so I'm going to write x equal to replace x is dot na, wherever I have is dot na x, I'm going to replace that with 0.
Mm.
So now I have, wow,
Mm.
I need to run that x. So see, 124504.
Mm.
All right. Uh, Next, I have matrix operations, data frames, and subsetting. But I think I've gone a little overboard with time. I can do 10 more minutes if you're up for it.
Ma'am, can I have this videos?
Yes, yes, you'll have this.
Some of this,
You will have this.
so that I can practice this
Of
because
course.
we need to practice.
Of course, of course. You will have this. Uh, uh, if you go to this data science forum, here
Yes.
below you will have some links to live sessions. It will be
Yes.
posted by NPTEL, and you will have access to a data sheet where you will have all the YouTube links and the folders where all these files will be stored. So it will come up, I think, very soon once we have one session done. All right.
Right, ma'am. Thank you
Okay.
very much.
Thank you. So this one, I'll just complete matrix operations, and then I'm going to end today's class, and the next day I will be talking about more on subsetting and plots.
Right.
So now
Matrix.
this thing is about matrices. So if I want in R, by default, matrix population is by column. So if let's say I have decided, sorry, I will have 147239825. First of all, what I can do is I can write it as a vector. So I can write 147292385. And if I give this to matrix and specify that n row equal to 2, n row equal to 3, n col equal to 3, I'm going to get this matrix.
Okay.
But if I save my data as this 123498725 and just write this thing, then I'm going to get by default 1 2 3 4 9 8 7 2 5. Let's just check this out. Okay, so sorry. So here if I give matrix C 1 2 3 4 9 8 7 2 5 and n row equal to 3, n col
And
equal
cos
to 3. So
3.
in order to define a matrix, I need number of rows, number of columns and the elements. See, I'm getting this thing because it's by default it's populating column wise. But if I want this exact matrix, then all I need to specify, okay, so default is by col. If I want the exact matrix that I said, then I need to write additionally by row equal to true. Then you see
Okay.
I'm getting this thing. Okay, if I don't specify, and if I also specify by call equal to true, that is actually the default. Oh sorry, by call, no, so I have to specify by row is the keyword, false, then that will
False.
give me the column thing. Okay, and by row equal to false is the default setup,
Different.
unlike what we usually think. If we have a thing, we'll fill up row wise and then proceed, but R does that column wise. Okay, so this is what now R, in R, matrix is nothing but a, sorry, where is this? Oh no, yeah. So here matrix is nothing but a 2D array. So if I have 1 2 3 4 9 8 7 2 5, then indices are like this. So row indices are stored like this, as you can see here, 1 2 comma
2.
3 comma, and
Mm.
here you have comma for all rows, 1 specifying 1 column, comma all rows 2 comma 3. So if I want to access 8, I should give my index as 2 comma 3.
2, 3.
Okay, so this is, if
Mm.
I want to, let me store this matrix as M, then if I give M 2 comma 3, I'm going to get 8.
Mm.
Okay, uh, now I want to do a transpose of this matrix. So in order to do a transpose, I have to give T of M.
Mm.
Let's say I want to get the determinant, then I have to give det M.
Mm.
Let's say I want to invert, then I have to give solve M. Now if I want to do matrix multiplication, if I give m into 2, what will happen? Each of the elements will get multiplied by
Multiplied by
2.
2.
Let's say I have two matrices. I have m1 equal to this thing, the default column wise, and m2 is the one that we have row wise.
Always.
This is m1, this is m2. Let me just print out m1 and m2. Okay, for the sake of clarity, I'm going to clear this and run again. m1, this is m2. Now if I give m1 plus m2, element wise sum will happen.
Summation.
Okay, m1 minus m2, element wise subtraction. If I give m1 into m2, then also I will have element wise multiplication. If I really want to do matrix multiplication, I have to give m1 percentage star percentage m2. This is going to give me the actual multiplication, matrix multiplication, row by column thing.
Percentage star percentage.
Percentage star percentage. Okay. Next thing is, I have this m1. I want a row sum, let's say. So I could just loop over these indices and do this, but a really efficient way to do is to use a function which is also called apply. So the way to use is apply, then matrix name. 1 stands for row, 2 stands for columns, where I want to apply. So if I want column sums, I'm going to give 2. I want operation on each of the columns. And then I'm specifying function, that is sum. And it gives me a sum of all the columns. So this is actually giving me column sum. If I want a row sum, apply m1 1 sum. It's going to give me row sum. I could just tweak it to get mean, row means. I could also use my own function to run on this. So to use my own function, all I need to do is I'll have to write apply m1 1 and then my function name, or rather this thing, function. So this is a little trickier. Let me just give a function name, myfunc. Okay, and I defined myfunc a equal myfunc equal to function a. I'm going to touch up on functions later. So I am returning a square. Okay. So myfunc is actually returning a square. So if I just okay, return I think will not work. And then if I give this thing, then I am getting the squared function across rows. or if I just want plus 3, something like this. Doesn't really matter if I have this sort of a function, because in essence all elements will be squared up in that sense. But if I want to have specific functions where I do, uh, let's say I change it, I say a1, or I know it's a 3 element function, it should be a1 and a2, something like this. So then this is going to give me 5, 11, 11. So along rows I am going to do. So first it will take this row 1, 4, 9, and then it will sum up the first one and the second one. So 1 plus 4 is 5. Secondly, it will take this row and they take the sum of 2 plus 9, it's 11, and then 3 plus 8, it will give me 11. That is what it is returning.
Mm.
Okay.
Yes.
So this was about matrix operations, and here are a few logical operators that I also discussed. So is true is another one. So if an expression is true, it is going to return 1, not is true is going to return false. Okay, and you can use these and or logical and or for carrying out these operations. And for vectors, comparing element wise, we have to use double and double or. Okay, and last thing I will briefly touch up and I'll also discuss in the next class is a little bit about subsetting. So I was talking about before this thing, let me go back to this my vector thing.
Mm.
So my vector is this thing. Now if I want only elements which are greater than a certain number, so I am going to write my vector, third bracket is should be interpreted as such that. Okay, so my vector such that my vector is greater than 5. So it's going to give me 6, 7, 8, 9. If I evaluate it by part, my vector greater than 5 is returning positions where elements are greater than 5. True, 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 true. So my vector such that this thing is actually fetching those elements where this condition holds. Okay.
Mm. Yes.
All right. So I'll begin discussing data frames and lists in the next session because I have gone way overboard. Thank you so much for joining, and if you please let me know if you have any doubts from today's session, any questions, anything, any comments, anything. Feel free.
Next, when is the next class, ma'am?
So next class will also be Saturday, 7 p.m., 7 to 9,
Okay, we'll
and
continue from here.
I will continue from here. And I think there will also be another session on Tuesdays. Something like this was posted here. I think there
On
would be
20.
2 live sessions. You could avail either of them. I will be, discussing these assignments on each Saturday, 7 to 9.
Right, ma'am. First, I will try to practice these
Yes,
commands.
please go
Then
ahead.
only I answer the questions.
Yes, of course. And if you have any, meanwhile, also, if you are unable to join the discussion for, the live sessions in any case, but I would urge you not to do that. I would request you to join and get your things cleared live. You can also post in the discussion forum and we'll try to
Yes.
address that.
Thank you very much, ma'am.
All right, sir. Thank you so much for joining. Have a good day. Bye.
Thank you.